Hi class, I want to talk about the heating curve for a substance. There's space on page 24 to write about this, and it's related to the stuff that's on page 31, which I'll turn to in a minute. But basically we have temperature versus time, and if we start off with a substance that was solid at time t equals 0, and we started heating it, the substance would start rising in temperature as the time went on. But at some point, the solid would start to melt. It would undergo a phase change. And the melting is going to be a flat line. It's supposed to be flat. So it's not raising in temperature anymore. Once it's done melting and it's all liquid, then the temperature will start to rise again. And then at some point, when the liquid's hot enough, when it reaches its boiling point, it's going to start evaporating, boiling rather, and turn into a gas. At that point, the temperature is going to stay constant again until it's completely turned into a gas, and then the gas's temperature is going to start rising like that. So we have solid in the beginning. By the way, this stuff is going to be on the Moodle page. All the notes I'm writing is going to be in the packet in the Moodle page. So it's solid during this section. Over here it's melting when it's flat. And when it's melting, it's solid and liquid. Some of it's solid, some of it's liquid. You can think about it like ice melting. You know, there's still some solid ice, and there's some liquid water going on as well. Then once it's all done melting, all we have is liquid. So going up here, this is all liquid. The liquid's temperature is rising, and then it reaches its boiling point, starts to boil. So we got boiling during here. The temperature is no longer rising, and while it's boiling, it's liquid and gas. So again, you could think about when you're boiling a pot of water, you've still got the liquid in the pot, but then there's the steam coming out of it. So you have both phases of matter there. And when it's done boiling, then you have just gas left. Okay, so in the regions when there are phase changes, like here and here, these are phase changes. That means we're changing from one phase to another. So, in other words, one state of matter like solid to liquid. So, here in the melting stage we have solid to liquid. Or in the boiling stage we have liquid turned into gas. And the phase changes, when the phase is changing rather, the temperature is not changing. Alright, temperature is not changing. The temperature does change in these slanted areas when it's just solid, just liquid, just gas. So that's when we're just heating up the solid, we're just raising the temperature of it. Or we're heating up the liquid, we're just raising the temperature. Heating up the gas, just raising the temperature. But at the point when it's melting or when it's boiling, the temperature does not change. So the heat energy that we're putting in, because we're adding energy, the added energy is potential energy, not kinetic energy. So when the temperature is rising, for instance, here, the temperature is rising, then the added energy, the energy that we're adding to this, is kinetic energy. Because when something has a higher temperature, it has a higher kinetic energy. But here, we're not changing the temperature, so we can't be changing the kinetic energy. So instead, what we're doing is we're adding potential energy. And now that might not at first makes so much sense because a lot of times when we talk about potential energy, we're talking about something being up higher, like a ball at the top of a hill. But if you think about, let me just get some new space here. If you think about the atoms or the molecules in a solid, the molecules are stacked pretty nicely, they're pretty close together, and they're vibrating. But as we turn to liquid, we're giving we're giving the molecules more potential energy. We're kind of pushing them apart. We're giving them some space. Alright, so that's why the liquid can flow a little more easily. There's a lot more space. They're not in this rigid pattern. The liquid molecules, they can fly all over the place. Not all over the place. They're still kind of held together because it's a liquid. But if we were to add more potential energy and make it a gas, then they would be really spread apart. Um, so just like when a ball is at the top of a hill, it has more potential energy. Potential energy has to do with distance, or sorry, potential energy has to do with position. So a ball at the top of a hill, because of its position, it has the potential to uh, change into kinetic energy. Same thing with when we add potential energy going from a solid to liquid. We've added some distance between the molecules, and that means that they can actually be pulled together. They have the potential to be pulled back together to become a solid. It's kind of like if you have two magnets, if you spread them apart, then they're going to want to try to come back together. So objects want to be in this nice rigid formation like a solid, but if we add energy to it, if we add potential energy, we can spread them apart. And so that's what's happening in the phase change areas. We're adding potential energy, we're kind of breaking the molecules apart, breaking the bonds so that they're spread apart. Alright, so again, in the phase change area, the temperature does not change, so no change in kinetic energy. But the energy that we're adding in becomes potential energy. We're adding potential energy in these phase changes. So no temperature change, we're just adding potential energy. So if you look on page 31, we made a prediction the other day about the water that was boiling, and a lot of people got it right. So I'm just gonna draw the Heaton curve again for water. I shouldn't have this, sorry. So let's say if the ice started at, we'll just say it started at negative 10 degrees Celsius. So if we're heating the ice first, it starts to rise. Once it gets to 0 degrees Celsius, it flatlines. The temperature doesn't change because that's where the phase change is happening. It's going from solid ice to ice and water. It's melting. After it finally melts all the way, it starts rising its temperature again. And for water, it's going to do that until it hits 100 degrees Celsius. That's when water starts to boil. So water boils 100 degrees Celsius and it stays at 100 degrees Celsius until all the water is boiled, and then it's gas, and then the gas can start to raise its temperature. So what happens to the temperature of a substance as it changes phases? The temperature stays the same. And again, that's because the energy that we add is potential energy, not kinetic energy. We're adding to the potential energy, not to the temperature and the kinetic energy. So let's now turn to page 32. That was a homework page. we've got these two questions. I want to make sure that you got them right. If you don't have them right, you want to change them. If you never did it, then you want to think about it and write them now. You might want to pause it and try it on your own. So the question says, energy is absorbed during which of the following changes of state? So solid to liquid, liquid to gas, solid to gas, etc. So we need to absorb energy in order to go from solid to liquid. We need to add energy to spread the molecules apart and make it a liquid. And we also need to do it from liquid to gas. All right. When we're adding energy to the liquid, we're able to boil it and make it into a gas. There is also a way to go from solid to gas, so we would circle that one too. That's called sublimation. We won't really talk about that too much. The same ideas go in reverse too. If you start off with a gas like steam and then you cool it down, it's going to condense into liquid water, and then it's going to freeze into solid ice. So that's when energy is taken away or released. So it's released when you go from a liquid to a solid. So that would be like water freezing. Or a gas to a liquid. That's like water vapor condensing. And again, gas to solid can also happen. That's called deposition, which I won't write because you don't really need to know it. All right. So again, we need to release energy or take energy out in order to go from a liquid to solid. We need to take energy out to go from a gas to a liquid. So now we've got this chart here. It says fill in the table below using the heating cooling curve above. All right, so what part is liquid only? So let's see. We've got solid, liquid, gas, and then this is solid and liquid. This is liquid and gas. So when is it liquid only? Between C and D. So you call it CD, or you can say like C to D. Alright, during this phase, or this area right here, where it's heating up in the middle, that's the liquid. Solid only would be in the beginning, A to B. Right here, we're heating up the solid. And gas only is at the end here, E to F. Now, when's it boiling? It's boiling when we go from a liquid to a gas. So this is boiling right here. And that would be D to E. And it's melting when it goes from solid to liquid. So that would be in area B to C. Alright, so if you didn't have that right, you should change that now.